session of Udhbhavana 2021, which will be deliberated by Dr. Nareen Chauhan, Assistant Professor, Shri Vaishnav Institute of Agriculture. Dr. Nareen Chauhan has joined SEEE in 2018 as Assistant Professor at Shri Vaishnav Institute of Agriculture. He qualified NET 2014 and completed PhD in Soil Science and Agricultural Chemistry. His specialization in soil science and plant nutrition. He explored his knowledge by working in different research-oriented projects in soil science and agricultural chemistry. He has contributed as Senior Research Fellow and Research Associate under the National and International National Project on Management Soil Health and Fertility and Maximization of Soya-bean Production in Madhya Pradesh, with the collaboration of Japan International Cooperation Agency. He is also versed in conducting baseline soil survey with GPS, mass collection of soil samples from farmers, fields in several districts of Madhya Pradesh for preparation of nutrient fertility maps. He has published more than 15 research papers in national and international journals, soil testing manual and Hindi manuals on organic farming for the use of local farmers. He was also awarded in his research presentation in national and international conferences. As we all know that today's session is on the topic, Indian soils are deficient in phosphorus rhizosphere. So without any further delay, I would like to invite our expert speaker, Dr. Nareen Chauhan, to start the online session. Over to you, sir.
Thank you so much, ma'am. Thank you. Am I audible?
Yes.
Thank you so much, ma'am. Honorable Vice Chancellor, sir, directors, head of the department, head of the institutes, and all the faculty members of SEEE. I, Dr. Narendra Chauhan from Institute of Agriculture. And today I am sharing my research experience, which was conducted during the 2012 to 2017. So let me share. Visible?
Yes.
So my today's lecture topic is Indian soils are deficient in phosphorus. There is a questions, and based on the research study, so many scientists reported that your Indian soils has a deficiency in phosphorus. But I think there is a questions on the view of the rhizosphere. So I will discuss today about what are the role of rhizosphere in the phosphorus availability in Indian soils. You know, the nutrients are required. There are 70 nutrients are required for plant growth and their development. These are some macronutrients, the nitrogen, phosphorus, and potassiums. These are the secondary nutrients, calcium, magnesium, and sulfur. And these are at micronutrients, which are required in less amount for the plant's growth. And these are the nutrients, the macronutrients, micronutrients, and major nutrients. But these are the major nutrients: nitrogen, phosphorus, and potassium. And in the absence of any nutrients, plant will show the deficiency symptoms. If suppose that your soil is a deficiency of boron and calcium, the plant will show the symptoms on the wood of the plants. And in case of your soil is a deficiency of nitrogen, the plant show the lower leaf symptoms, just like the burning of your crops. And unfortunately, Indian soils are deficient in nutrients. Are the major nutrients are the nitrogen, phosphorus, and the potassiums. More than 60% soil samples of nitrogen is deficiency in our soils, 42% samples phosphorus deficiency in our soils, and only the 30% potassium deficiency in our soils. But fortunately, it's good for us that our soil is a good status of the potassium in our soils. But similarly, in case of the nitrogen, all the nitrogen, the major nitrogens are the deficiency in our soil. And especially in the zinc, our soil is almost 50% of our soil is a deficiency in a zinc in our soil. And in case of over the year, since 1950 to 2020, year by year by year, the nutrients has been exhausted by the crops, and day by day, our soil is being deficient. So this is the very serious concern about our soils. Our soil is not thirsty, is hungry too because of the lack of the nutrients over the year. And in terms of the population of the India, 1950 to 2050s, our population is day by day increasing growth rate of our populations. And it will be by 2050, 1.6 billion populations in India. And nearly soon we are going to cross China, and we are going to secure our first position in the population of the India. So this is a matter, is a very serious matter, because we have to feed all the population of the India. And our food productions over the year in 1950 to 15 million tons, and definitely we have achieved our growth by the 2021 308 million tons. And what about the future productions by the 2050? At almost we have required 337 million tons food are required to fulfill the requirement of the population of the India by 20. And we have a problems. In 1950s, we had a 0.34 hectare per capita level land, but now it has reached by 2025 0.0 hectares. And we have a limited area, and we have a required more food for the 1.6 billion peoples. So definitely it would be possible if we adopt a new technology, either multiple cropping system, vigorous seed, superiority, genetics, purity seed, proper irrigation system. If we adopt the high yielding variety, if we apply the balancing use of pesticide or the fertilizer. Nowadays, we are continuously applying the blind application of the fertilizer. So we have to think we should be apply the balancing use of fertilizer. And we have to adopt the modern technologies in agriculture. We have to manage the waste management and soil conservation, and so on. So many technology we have to apply if we want to get achieve our productions. And the overview of the agriculture scenario, definitely we can achieve in an easy way, because agriculture has done everything in the field of agriculture. Either in case of the GDP, it contribute more than 70-80% of the GDP from the agricultures, and agriculture is the primary source of livelihood for the 58% population of India, and agriculture generate the 50%, more than 50% of the Indian workforce. And agriculture sector is India is considered to the backbone of economy. And how we can forget the role of Indian women in agriculture fields in terms of the value, volume, and number of housework. They work more and more works. So we should not underestimate the power of the common woman in agriculture. And if we come to the phosphorus is a major nutrients. It's play a major role in crop productions. And the phosphorus many important function in plants, primary one being the storage and transfer of energy through the plants. Phosphorus is a vital component of the ADP, is called as a energy units, stunt root development, or increase the stalk and the stem strength, and improve flower formation, the seed productions. And for the estimation of phosphorus from the soil, we are using the Olsen method. This method was given in 1954 by the Olsons, and he reported that this method is used generally we should use for our soil, which is called what is called the black soils. So based on this method, Olsen method, we estimate this soil is a deficient, this soil is a medium of phosphorus, this soil is a high of phosphorus. So this is the Olsen method we are using since 1954, and based on the phosphorus in our soil is fixed in the form aluminum phosphate, iron phosphate, and calcium phosphate. And the available phosphorus comes from either some little from aluminum phosphorus, from aluminum, from iron, from calcium phosphorus. So this is the available phosphorus. This is the fixation of phosphorus in our soil. And our soil is but the fractionation, these are the fractionation of phosphorus, aluminum phosphate, iron phosphate, and calcium phosphate, and the dominant of phosphorus depend on your soil. This suppose that your soil is a black soil, this is the red soil. The black soil is a rich of calcium bond P. There is a rich of calcium bond fixation P. There is a iron and aluminum bond P. So plants uptake from the some little portion of the calcium from some little portion from the aluminum and iron from. And the Olson reported that the plants uptake phosphorus from the aluminum and iron bond, majorly, dominantly uptake from the aluminum and iron portions, and little bit from the calcium bond P also. So, but it is uptake by the phosphorus by the plants only a small amount from the calcium P. But fortunately, our soil is rich of P, because as a black soil, that is called the vertisoil, rich of P, but unfortunately it's uptake a little amount of P. So this is the bioavailability of a new phosphorus. If our soil is acidic, so its phosphorus bond with the aluminum iron. Our soil is a neutral, the pH is 7, so it's the free of phosphorus. If our soil is higher, so it will bond with the calcium bond P. So he also report that your soil is a little uptake from these portions, aluminum and iron, and not from this portion. It's uptake from calcium also, but it's a little portion of the phosphorus. And the scenario of soils of Indian. This is the all our soil has been classified in 12 order. This is the world soils. There is a 12 order. So we are talking about only the vertisoils. This is distributed in a large area in India. This is the antisoils and septisoil, and each soil have a specific character. And this is the vertisoils. And vertisoil is a rich soil in India, especially in the central zone of the India. This is a rich of calcium, but unfortunately, this calcium is not available to the plant. But rich of calcium bond P. But it is not available. Only little portion of this P is available. And this is the character. This soil have a character of shrinking and swelling characters. During the summer season, it shrink. And in case of the rainy season, is swell. It's showing the symptoms just like you can see here. This is the character of the soils, of vertisoil soils. And our soil is it is around the 30% of Indian soil is black soils. So this is the large area of the black soil in Indian soils. This is the vertisoil soils. And in case of the Madhya Pradesh also mainly covered by the black soils. That is a vertisoil black soils. So this is only this portion of Shivni, Gwalior, Morena. This is the alluvial soil. No doubt, this is a rich. This is the fertile soil, also fertile soils. But deep black soil is the Malwa zone of the Madhya Pradesh. And but how we can say this soil is a deficient, this soil is sufficient of P, this soil is a higher of P, based on this criteria. After estimation of the phosphorus by the Olson method, if having the phosphorus is less than 10 kilogram in prati hectare, so it means your soil is a deficiency of phosphorus. If your phosphorus content is 10 to 25 kilogram prati hectare, it means your soil is a medium of phosphorus. If it goes more than 25 kilogram, it means your soil is a high of P. So based on this criteria, we reported our soil is deficient or sufficient. So based on the criteria, we estimate the soils of India since 1969 to 2011. Year by year, we evaluate the soil fertility in respect of phosphorus. We found, unfortunately, our soil is a deficiency of phosphorus based on the Olsons. And similarly, our samples is deficient. Only few samples were found is a higher of phosphorus. Low and medium samples is more than 90% deficiency. If we join the low and medium, so more than 90% of soil is either the low or the medium of phosphorus in Indian soil. Similarly, status of Madhya Pradesh soil, and similarly in Indore districts, but there is no deficiency of phosphorus. and some samples is where maximum or higher phosphorus, and some is a medium of phosphorus status in Indian soils. If phosphorus is low in your soil, the plant show just such like of symptoms, purple color on the leaf. You can see some example of the tomato, cotton, maize, oat. They are showing the deficiency symptom in soil, phosphorus deficiency symptom in soil. And in early stage of the maize will show such type of symptom if your soil is a deficiency of phosphorus. And to fulfill the requirement of the fertilizer, we continuously applying the fertilizer after the 1950 to 2016. There was only the less than 1 kilogram per hectare we were applying the phosphorus. And now we have reached more than 130 kilogram per hectare. And similarly, the total fertilizer applied the 0.07 million to 25, more than 25 million tons fertilizer we apply the more fertilizer. Here we are increasing the application of the fertilizer to achieve our food productions. And you know the rhizosphere, that is the surrounding area of the root zone, which is influenced by the root activity, that is called the rhizosphere, and it may be by the area may be by the 10 mm, that is called the rhizosphere, which is mostly influenced by the root activity, because root exudes there is a lots of microorganisms. The population of microorganisms is high surrounding the rhizosphere. Root lead the compounds into the soils. These are called the exudates. These exudates include the amino acids, hormone, enzymes, metabolism. Exudates are key to the plant soil microbe relationship, and these are the root exudates. That is the sugars, amino acids, organic acids, and other protein enzymes. So these are the rhizospheres, the activity of the rhizospheres. And the question is that our soil is a really deficiency of phosphorus, because there is a question, because some scientists has reported they apply the phosphorus in the soils, but they did not get the response of phosphorus in the crops. Some, either the AE or the Sahara, then some very famous scientists in the world, that they reported why your soil is not responding to phosphorus. Either your soil is a rich of phosphorus, that's why it is not responding to the fluorocarbon fertilizer. There is just some chemistry or the biology behind the not responding of the phosphorus in your soils. So there is a questions. The question is that they raise the questions that the phosphorus movement in very slow in your soil. The movement of phosphorus rate is 0.13 mm per day. It's very slow movement of phosphorus. If you apply the phosphorus into the soils, they move very slow, only 0.13 mm per day. And you know the phosphorus, the plant to plant and row to row distance of the soybean, it is around the 45 into 15 centimeter. Row to row distance is 45 centimeter, and plant to plant distance, which always suggests to farmer. The row to row is 45 and plant to plant 15 centimeters. And suppose that your phosphorus, you apply the phosphorus is there. Here is a phosphorus, and distance is more than 12 mm, because the duration of the soybean plant is almost 90 days. From sowing to harvest is duration about 19 days. And after that harvested, is it possible this portion, there is a phosphorus, can move towards the roots within 90 days? Because in 90 days, it will cover the distance only 11.7 millimeter. So it is very difficult to that portions may be uptake by the plants, these portions of the phosphorus. So in this case, why plant are responding? Because this portion is not available, but still plant are growing well. Because there is a root zone, there is a rhizosphere. The rhizosphere can dissolve the phosphorus and can get easily uptake by the plants. So rhizosphere play a major role for the availability of phosphorus. And when we apply the phosphorus into the soil, only 15 to 20% phosphorus is available. The remaining 80 to 80% phosphorus is fixed in the form aluminum bond or the iron or the calcium. Only little bit amount of phosphorus available to the plants. And next question is that during 1960-97, if we applied the 1 kilogram of nitrogen, so we got the 13 kilogram of grain. But year by year, we're getting the lower response. We apply 1 kilo, only getting the 8.2. Year by year, and now by the 2010, only 3.7 kilogram. So why our fertilizer are not responding? Why? That maybe our soil has rich of fertilizers. That's why it's not responding. And unfortunately, the fertilizer consumption rate is very different. It vary. It is national average is 135 kilogram per hectare. But some states are applying excess use of fertilizer. 205, 29, 225, 337 kilogram per hectare. They are applying overuse of the fertilizers. And some states are very less, applying the very less amount of the fertilizer, 48, 50. And some northern state is only 3 kilogram. So there is a not proper distribution application of the fertilizers. And we give the new concepts. Why soil is not responding to the fertilizer application? We conducted a small. Firstly, we find out the pH of the root rhizospheres. So this is the non-rhizosphere soils. We choose the 3 soybean, chickpea, and this is the non-rhizosphere soil at the pH of 7.8. So this is the non-rhizosphere soils. We remove the plant and shake the plant. This soil is called the rhizosphere soil. This is the attached soil. So the pH of the suppose the chickpea, but the pH is decreased. It is around 7.1, and this is the root surface that is called the rhizoplant. That is the pH is 5.7. So the difference between the rhizosphere and non-rhizosphere soil is a 2.1 unit lower. So there is a very big gap in the pH between the rhizosphere and rhizosphere soils. So this lower pH play an important role for the availability of phosphorus in the soils. And one another test to find out the pH of the root rhizosphere. Rhizosphere, we have earlier discussed the pH. There is a root exudate. There is a lots of microorganism populations surrounding the root zone. And based on the indicator, we find out the pH of the root surrounding the root. This is the roots of the soybean and the gram and the sorghum. And the pH of the crops vary to the crop species. This is suppose that these are the different species and these are the pH of the difference. So it's vary, the pH vary on the crop species, but in the gram exudates more and more amount of exudate. There is a lot microorganism. There is a higher microorganisms. So it's showing the yellow color showing in the, you can see here the pH, the 5.5. This is the, so this is showing it has been proved that your soil is acidic. So acidic soils in some another scientists also reported. And this is the soybean, the fava beans, and the maize. So the pH is acidic in the roots. So this is our hypothesis. Our hypothesis said that our soil is a vertisols. There is a calcium rich of phosphorus. You can see the nodules. You know the calcium nodules, white color. This is the calcium. There is a P bond calcium phosphate. But Olson, I think he did not consider the rhizosphere theory, but we consider the rhizosphere theory. And our hypothesis is that these calcium nodules dissolve the phosphorus by the acid formation by the roots. And this phosphorus can easily applied by the plants. And we are consider only these portions. And we are not consider the soil availability P. I think we should consider these portions. We are not considering yet. We need to be considered this portion because our soil already rich of phosphorus. So why we are wasting up application of the fertilizer, we should be consider the rhizosphere pH, and our soil already is a vertisol rich of calcium P. So why we are applying of the fertilizer, more and more application of fertilizer? And so the soil, this is the, we also called is a hot spot for the microorganism, for the nutrient availability. This portion is called the rhizosphere, and this portion can dissolve with the phosphorus, which is a fixed in the calcium bond P. And this is the rhizosphere. And it's maybe depend on the crop species. Your crop is a pulses or granules, is vary for the root decreasing the rhizosphere pH. But this is the hottest spot for the microorganisms. And as I told you, you depend on the root biomass, crop species, and this is the different crop roots. This is the roots of root zone of the different crop that will help to solubilize of fixed form of P from vertisols. And we conduct to find out the result. We conducted so many field experiments. As Olsen is already reported by the Olsen in 1955, he generally used the sodium bicarbonate in pH at 8.5, and he reported for the vertisols, but we try some more methods, that the Bray, Mahalich, and Frog. And why not we should be test some more methods? And we collected the low phosphorus soil, medium phosphorus soil, and high phosphorus soil based on the Olsen method. This is our low phosphorus 3 soil, low medium phosphorus, and we and this soil also conducted evaluated by the other method, the Bray method, Frog method, which is used in some for the other soils. And we also estimate the bond, calcium phosphorus, calcium bond P, element P, and iron. And as I told you, our soil is rich of calcium. But unfortunately, this is not available as per the Olsen. As per the Olsen, he reported this portion is not available. But we are saying that this is also available to the plants. That's why your crop is not responding. And he reported this portion is available to the plants, and little bit maybe this the calciums. So we conducted the field experiment. This is our technical program to conduct the field experiments. The soybean crop in variety GS9305, and these are the 4 treatments, the replications. And this is our view of the pot experiments, and we apply the phosphorus in low phosphorus. In low phosphorus, we apply the fertilizer in low phosphorus soil. We apply the fertilizer in medium phosphorus P. We apply the fertilizer in high phosphorus P, and we found the magical result. There is a no response. There is a no response even the application of fertilizer in medium P soil. So why our soil is not responding? That's why your soil is rich of phosphorus. You don't need to be applied too much fertilizers. So similarly, different places we conducted pod experiments of fertilizers, and these are the some pod experiment. There's some field experiment also we conducted, and we find this is the result. The right now we are using these methods. But based on the result study, P uptake, phosphorus uptake by the soybean crop, the correlation regression study R square is only 0.49 regressions. But in case of the Bray, R square is higher, 0.82. And another method is also used, but it's not correlated well. But I think there is a two method is good, but I think based on the result, Bray is better than the Olsen's. We should be consider the rhizosphere theory based on the consider the uptake by the soybean is best by the, if we estimate the phosphorus by the Bray 2 followed by the Olsen's. So this is a good. And the Olsen said the phosphorus uptake by the aluminum and iron and little bit the calcium. But in our study, we find out that the calcium is a majorly uptake like that 0.844 lesions study. And in case of the aluminum P, 0.57. And in case of the iron, 0.55 regressions. So this is the better study. It is good result we find out. And this is a one magical research conducted by the scientist Noriharu AE from Japan. I worked 4 years with Dr. Noriharu, and he selected two different soil, black soil and red soil. And same soil is black soil and red soil. He chose the two crops, sorghum and pigeon pea. Pigeon pea, red gram, that's mean arhar, tuar, arhar. So in black soil, and both soil is a deficiency of P. Matlab, there is a no phosphorus, a very little amount of phosphorus. There is a little amount of phosphorus in both soil, but still crop grow well. Why? The black soil, there is a no phosphorus, there is a deficiency of phosphorus, but sorghum grow well. But in red soil, the crop is not grow well. In similar soil, the black soil, the pigeon pea grow well, and red soil also grow well pigeon pea. In both soil grow well pigeon pea. This is the very magical research. And why this happening? Why? So you find out this is the vertisols. There is a only small amount of phosphorus deficiency, but still grow well the sorghum. He find out the calcium bond P is rich. There is a calcium bond P is rich. That's why growing well. And in case of the red soil is a alpha soil. The calcium bond P is a very little amount, small amount of phosphorus. That's why it's not growing. So he reported that your crops mainly dominant of calcium bond P and uptake on the calcium bond phosphorus. There is a no calcium bond phosphorus, plant cannot grow well. But there is a calcium bond phosphorus, plant grow well. Even though you estimate the phosphorus, your deficiency in phosphorus, but grow well. But why in both soil grow well? He find out this is a special case in the pigeon pea. The pigeon pea can use the iron, this is the iron bond P, aluminum bond P, and a calcium bond P. And your pigeon P or arhar can uptake from all these major fractions. So there is no restriction for the fractionation. They cannot, there is no choosing the crop. They can uptake phosphorus from either the iron ho, either the calcium ho, the aluminum ho. So that's why it's growing well. And he find out the similarly reason. He found the uptake of P by the sorghum is majorly from the calcium bond P. A little bit maybe the aluminum iron, but it's just opposite. Olsen said that plant is uptake only the aluminum iron. That's why our soil is a deficiency, he reported. But fortunately, our soil is a rich of calcium and plants uptake only the calcium bond P. And the pigeon P uptake calcium bond P, aluminum P, from the iron P, all these free from P. So in some another field experiments, this we conducted the field experiments. This is our treatment details, levels of phosphorus, the soybean, so already. So this is our details, and we find out again the result, good results. This is we applied the P0. There is a no applied the phosphorus. P 30 kilogram phosphorus, 60 kilogram phosphorus, 90 kilogram, and up to 120 we applied. And based on the application, the total dry matter yield and seed yield of soybean. So this is the seed yield, this is the dry matter yield of soybean. So there is no applied of phosphorus, but this is the similar yield. Similarly, even though you applied and not applied, the yield is limited, almost similar, no significantly difference. Little may difference, but there is no significant difference between the applied the phosphorus and not control. This is the graphical present. This is a table. This is no significant difference. This may be a little bit difference, but there is a no significant difference. So some other experiments with the 0 up to the 180 we applied. So there is not a significantly difference in the yield and the uptake of the phosphorus by the soybean crops. So These are the view of the some field experiments. This is zero. There is a control. There is a no application of fertilizers. But we apply here in 90 kilogram of fertilizer. Almost same crops. There is no difference. So why we are application of the fertilizers? We should be reduce the doses of the fertilizer based on our study. And these are the some other experiments, the field experiments we conducted. The P, there is a 0, with 30 kilogram per hectare, with 120, with 90, with 60s. I think the crops are almost the same crops. There is no majorly differences to the application of the fertilizer in the crops. And if this is the our outcomes of our study, by using the Pareto methods as recommended may be the helpful for the enhancing the P efficiency in vertisols. The estimation of available P from the rhizosphere point of view in the calcareous vertisol will help in the reducing the P application rate considerably. As we know, most of the P fertilizer used in India are being imported, which is involve a lot of foreign money. But reducing the P application rate without decreasing the crop productivity will reduce the requirement of fertilizer, P fertilizers. The cost of cultivation will also reduce and will help in the enhancing the profitability of farmer and in one of the step for the doubling the farmer income. So, and this is the common problem every year during the Rabi, during the sowing of the gram and wheat, shortage of the fertilizer. So I think कुछ हद तक इस समस्या का भी हम problem ये solve कर सकते हैं if we apply the new methods. And this is the future plans. Some more on from trials and field experiments should be conducted at different places. I mean the different state and in different soil also. And the re-evaluate the critical limit of evolution method is required for the different types of soil, because critical limits mean we estimate the critical limit is below the 10 kilogram your soil is a deficiency. I think it's time to re-evaluate, because this critical limit we are using since 1954. So it's time to re-evaluate the limits. And critical limit of phosphorus for Pareto should be determined by the different soil and crops. To be analyzed the different soil microbes activity in bulk soil and the rhizosphere soil. To be analyzed the phosphorus solubility by different crop exudates. To be analyzed the amount of crop exudates by the cereals and pulses, and need to be assessing the impact of rhizosphere on the catchment P. And if we shift to another methods, suppose that if we shift after analyzing the study, we shift to another method. In nowadays, we are recommended the nitrogen, phosphorus, and potash at 20, 60, and 20. This is the 20 kilogram of nitrogen, 60 kilogram of phosphorus, and 20 kilogram potash. We recommend to the farmer for 1 hectare for the soybean crops. In case of the wheat, 100, 60, and 40 kilogram nitrogen, phosphorus, potash. Suppose that we adopt the new methods, Pareto, that is called Pareto. So what is the new dose of fertilizer, phosphatic fertilizers? Here is we have fixed 60 kilogram per hectare and 60 kilogram per hectare for the soybean and wheat. And what about for the new methods? There is a question. So this is the required this studies, how much we should be applied. Definitely will decrease the doses of fertilizer if we shift to another method. But how much is a matter of our research. It is a matter of our study. And your research is nothing until you published any papers. So over the time to time we be published on this so many papers. And last week and the last month we published a paper in Japan Soil Science and Plant Nutrition released by the Taylor and Francisco in the Japanese journals. So this is this was our study. So thank you so much. Thank you so much.
If somebody has any queries.
Sir, your mic.
Yes. Naren sir,
Yes, sir.
I just want to know that how these plants they absorb different nutrients, or they are having same mechanism?
No, sir, there is a different mechanisms. Suppose that we are talking, suppose the phosphorus uptake by the diffusion process. It's very slow in a soil.
Yeah.
Mass flow, diffusion, root interceptions, different mechanisms.
And so this yeah, rhizosphere is directly related with rhizobium bacteria.
It may be, sir, because we study on the rhizosphere to know the pH of the soil, rhizosphere soil. Because with the help of the microorganism and roots exudates, it helps to decrease the pH, and that decreased pH will help to solubilize the calcium bond P. And calcium bond P is already higher in amount in our soil.
Okay, sir. Thanks.
Mr. Dr. Narendra Chauhan, have you done any experiment like you were telling, that phosphorus is already in adequate amounts in the soil? So, have you done any experiment eliminating phosphorus from the fertilizers?
Yes, sir.
By eliminating phosphorus completely from the fertilizer.
Yes, sir. We also
We put only nitrogen and potassium in, and no phosphorus.
we conducted the experiment, sir. There is a control. There is no fertilizer applied. I have shown in our field and board experiments. There is a control. So there is a not significantly difference if we apply the fertilizers, phosphorus. So there is a no significantly difference.
You are relating to the phosphorus.
Yeah, relating to the phosphorus.
But controls don't have even nitrogen and potassium.
We apply all the nutrients except the phosphorus.
Actually, you are applying the nitrogen.
All the phosphorus except the phosphorus. All the required fertilizers, all the required fertilizers be applied. Except phosphorus.
So you are not applying NPK there.
No, sir. We applying all the fertilizers as required for the plants. But in control, we didn't apply the phosphorus to find out the difference between the applied and non-applied phosphorus.
Okay, and then the difference in the plants, like you were showing between sorghum and that Cajanus, right?
Yes, sir.
Cajanus.
Yeah, Cajanus.
So Cajanus can take phosphorus from both iron and calcium.
Yes, sir.
Why sorghum cannot take that?
Well, actually, Mr. The Noriharu report is some special type of exhibit. I have no idea, but there is some special cakes, and I think we should find out some more crops that can only the iron phosphorus. They choose only iron bond phosphorus. There is some special kind of exhibits that dissolve with the iron bond P, especially dissolve iron P. That's why they apply.
It may be dependent on the exudates of the roots.
Yeah.
Because the root exudates of Cajanus may be different from the root exudates.
Yes, similarly. The pyxinic acid, just like the pyxinic acid.
Have you analyzed this root exudates of sorghum and Cajanus?
Just I find out the pH of the roots, sir.
No, not on the pH. pH may be, pH is just one factor. But because this seems to be very specific for dissolving the bond between phosphorus and aluminum. So there must be something else other than pH.
Maybe.
Because pH can be changed in any case, even
yes,
by just altering the pH, the calcium bound phosphate and aluminum phosphate, both may be dissolved by altering pH, right?
Yes, sir. But actually, Mr. In generally our soil is a higher amount of the calciums. And still we are reporting that our soil is a deficiency as it's mentioned in
that I understand.
Yes,
your whole point is not to
I think we are
not to enrich the soil with phosphorus because there is sufficient phosphorus.
Actually, sir, we are not just blaming to the ocean is not good. Ocean is also good, but I think it's time to reevaluate the soil fertility. It's time to reevaluate the fertility based on the
Yeah,
So we can actually with the help of
I think you can study further the differences which you are getting between the plants, because there is something fundamental about it in the root exudates.
yes,
Because if Cajanus can dissolve the bond
iron.
between aluminum and phosphorus, and sorghum cannot dissolve it. Now there is a fundamental difference.
Yes.
So I hope you will look into this sometime.
Okay, definitely. I mentioned the future plans, sir. If I got opportunity, definitely I am ready. I'm agree.
Okay.
The
Okay.
main
Thank
difference
you.
between Olson's method and the
Yeah.
other scientists that you spoke of is that in Olson's method, we take a sample that is a bulk sample,
Yes.
not considering the rhizosphere.
Yes.
Whereas the other scientist that you reported takes a sample from the rhizosphere, and there the pH is varying. As you go nearer to the rhizosphere, the pH decreases, isn't it? As you showed in the table. So, in what form should the phosphatic fertilizer be applied to the soil?
So in generally, we apply the inorganic fertilizers, sir. And after the application of the fertilizer into the soils, they make the form. Is the aluminum, the irons, the calcium, based on the nutrients. Suppose the aluminum is high, calcium is high, iron is high, so they make the bond and they fix into the soils. There is a problem in our soil.
Diammonium phosphate,
DAP or the SSP or the single
then
super phosphate.
SSP.
Mm.
So, whose solubility is more in the soil? In case, related as we are considering the solubility of phosphorus.
So solubility is almost solubility is similar. There is a not a differences.
So, what is the question remains? If the soils are rich in phosphorus,
Yeah.
why isn't the uptake by the plants?
Why it?
Why shouldn't the plants uptake it? If the availability is there, why don't they utilize it? What restricts the phosphorus?
We conclude, sir, phosphorus is uptaking by the plants. Uptake the the question
right,
is on the question on question is
whatever it's not the phosphorus is not absorbed by the plant through leaves. It's always through the roots.
roots.
If the root zone is sufficient in phosphorus, so why plants do not make use of it? What restricts them?
Plant is uptaking the phosphorus. It's no doubt, sir. Plant is uptaking the phosphorus, but we underestimating the phosphorus by the Olsen methods.
That's
We are underestimating the
There's an
phosphorus.
estimation part of it. There's an
Estimation part. Plant is
estimation part of it.
estimation part is there.
And there's a difference because
Difference.
Olson's took a general soil sample, not considering the rhizosphere,
We are not considering, sir.
whereas other scientists has considered the rhizosphere.
This is our new criteria based on our little bit experiments based on this criteria.
So, what should
actually,
you recommend? In vertisol, shouldn't we?
No, sir. I will recommend all the soil having the high calcium bond P. Where is a high calcium bond P? We can recommend because the Olsen.
That is what I am asking. So, what form of fertilizer, phosphatic fertilizer, should you recommend?
In generally, inorganic fertilizers in the form there is no form.
Inorganic तो है ही, inorganic तो है ही.
Either the DAP or the single super phosphate.
जैसे आप कह रहे हो ना calcium bond.
There is a no. There is no bonding of different forms of phosphorus. Generally, we apply in the form of diammonium phosphate, calcium ammonium phosphate, single super phosphate, mono ammonium phosphate.
जैसे आप कह रहे हैं ना जो release है, जो release of phosphorus है, वो कैल्शियम बॉन्डेड से ज्यादा होता है इन कंपैरिजन टू एल्युमिनियम एंड आयरन। ये कहना चाहते हैं ना आप?
यस सर।
तो आप ये कहना चाहते हैं कि जो इनऑर्गेनिक फर्टिलाइजर जब हम इस्तेमाल करते हैं वो किसी भी फॉर्म में हो उसका कोई असर नहीं पड़ता?
यस सर, क्योंकि हमारी सॉइल में है वो ऑलरेडी, रिच है हमारी सॉइल में, तो इसलिए नहीं अपना।
हाँ, बाकी जो
हाँ रिच है।
बाकी खैर थोड़ा भी मैं क्लियर नहीं हूँ उस पर। बाकी जो डॉक्टर गुरुप्रसाद सर कह रहे थे वो बात सही है कि जो बाकी भी रूट एक्सिडेट्स हैं राइजोस्फीयर, उनका इन्फ्लुएंस क्या है फॉस्फोरस पे, जो अपटेक ज्यादा हो रहा है या लिमिटेड है, उस पर स्टडी होनी चाहिए।
ये स्टडी मस्ट बी सर, definitely must be, because we studies here only the pH point of view.
Yeah, you see, the pH point of view is fine, but that's a general phenomenon.
Must be sir, must
be. But the problem is, like, your sorghum will not grow in a red soil, because even if the phosphorus is available, it is in the form of iron in combination with iron, and that it is not able to take it up. So, like Professor Vinod is asking, so in what form the phosphorus is available becomes important.
Yes.
If you grow sorghum, for example, if you grow sorghum in red soil, then you need to supply calcium phosphate. There is no calcium phosphate.
That's what I'm asking.
Or you have to give it in ammonium phosphate or something.
So, it may be possible if this is the matter of the chemistry. If you apply the aluminum bond phosphorus, a calcium bond phosphorus, a iron bond phosphorus, the chemistry of the fertilizers, this is
no. That is chemistry. No, it's also biochemistry.
Biochemistry.
Biochemistry. What we need to look to is the biochemistry part of it. That one plant is able to uptake this iron phosphate, and other is able to uptake the calcium phosphate. So there is a difference in the biochemistry of the plant. That biochemistry will be in the root exudates. There are two possibilities. One is the root exudate. Another possibility is what are the microorganisms which are inhabiting the rhizosphere. That may also make a difference. The rhizosphere of black soil and rhizosphere of red soil will be different.
So
microorganisms will be different.
Microorganism and also very crop to crop. In case of
crop to crop and also the type of microorganism.
Cereals crop and pulses crop, very differences.
That is also there.
And the interaction between the phosphorus, nitrogen, and potassium, that also influences the interaction of nutrients. So we should be clear in sending the message to the farmer in what form the phosphorus nutrient should be applied through fertilizers.
Actually, I think this stage should be carried forward because of we don't know how much phosphorus dissolved from the calcium 1P. There is one step. The area of the particular of the rhizospheres, that much how much amount of the exudates from the roots. This is a matter of the studies.
So Vinodar, I think what his study shows is that at least in black soil, phosphorus is not.
Oh yes,
that is one thing, because he has been working in these areas where black soil is predominant. But in other soils, then one needs to study, because all crops may not be able to uptake the iron phosphate. So there you need
studies, yes.
Okay.
Nowadays you have phosphorus solubilizing agents also.
Yeah, microorganisms. We use some microorganisms, pseudomonas.
So they help.
They microorganisms help to solubilize the fixed form of calcium 1P. Pseudomonas, vesicular mycorrhiza, some fungi, some bacteria also responsible for the dissolve of the phosphorus.
Oh yes, good. Thank you. But you need to go for further studies.
Yes, sir. And different soil. I mentioned in the future plan we need the more study in different soils, sir.
Okay, thank you.
Okay, Shukla sir.
Okay. Thank you, Naren sir, for sharing your valuable knowledge with us. I would also thank Dr. Vinod Dhar sir and Dr. K.N. Guruprasad sir for making this session interactive. I am also thankful to our Vice Chancellor sir for being with us. Dr. Ashutosh Shukla sir, Coordinator Udhbhavana. I am also thankful to the technical team of SVIT for their continuous support in taking the online events. Thank you everyone for being with us. The next session, that is the 6th session of Udhbhavana, will be on 17th of December this year. Thank you all for being with us.
Thanks, Chauhan sir. Thanks.
Yeah, next Udhbhavana कब है?
Sir, 17th December को है.
Okay. Who will be the speaker?
Sir, we will decide in few
अभी
days.
decide नहीं किया है.
Most probably from engineering technical section session, sir.
Okay.
Yes, sir.
ठीक है, अच्छी बात है.
Yes.
All right.
Okay.
Thank you, sir.
Okay.
Thank you.